So in this video, we're going to talk about the rules for significant figures. What are they? Why are they important? What does it matter? So first off, what's important about them? Why are things significant in physics and numbers and measurements? Well, part of it is the resolution of what we can measure with only allows for a certain level of precision. So if we look at this pencil right here, it's only labeled in centimeters, so we can really only say that this pencil, based on its length here, is 16 centimeters for certain. We could estimate maybe one digit past that and feel okay at 16.0 centimeters. But because of that resolution of the ruler isn't that great, we are limited to what we can actually say about the length of this pencil. However, if we switch rulers up and now we go to a different ruler here that has millimeter delineations, we can see that we know that this ruler here is exactly 14.0 centimeters. Okay, and we could even potentially estimate and say, you know what, I know that it doesn't even go even close to the next millimeter at all, so we could say it's 14.00 centimeters. So again, by adding to the resolution, it's going to allow us to add precision to our measurement. So our measuring devices are going to be what limits our ability to add precision to our measurements. And what's important about that? Well, for a problem-solving application, for this whole thing, when we're working all these math problems out, we can't add precision to a problem. Okay? We can't add precision that we don't have. We're limited by the level of what's called significance and all the information that's been given to us. Might be wondering though, like, what does this mean if we're not given some of the information? What if the numbers aren't things that we measure, someone else did it? Well, then we need to know what numbers are significant in the numbers we're working with, and that allow us to give certain amounts of precision to our work. So there are some rules for that. Here are the rules for making digits significant. So the first rule is any non-zero number is significant. So I'm going to do 3 different numbers. All of them have 4 significant figures. So 1, 2, 3, 4. Let's do 65.86 and 7251. All 3 of these numbers have 4 significant figures. And a lot of times I'll just label significant figures as SF. On your quizzes or things like that. Hey, that's what I'm talking about. If you see that, that means that tells you whether or not something is significant or not. So any non-zero number, of course, somebody measured it, they know it's not zero, so that makes it significant. Okay. So second rule is sandwich zeros. Well, what the heck is a sandwich zero? Well, here's what a sandwich zero is. A zero that is sandwiched between 2 significant figures. Okay. So or multiple significant figures on each side. So say we have the number 1002. Those 2 zeros in the middle are significant. Again, we have 4 significant figures in this number. If we have the number 1105, okay, again, we have 4 significant figures. That zero is sandwiched in between 2 non-zero numbers. If we have the number 21 or 2014, again, we have 4 significant figures because that 0 there is sandwiched in the middle between our non-zero numbers. Okay, so the 0 numbers are ones that are sandwiched in between. Now, the next rule is the decimal point rule. What does that mean? Well, that means if we put a decimal point in a number that is greater than or equal to 1, every digit in there is significant. So if we have the number 1.000, it is going to have 4 significant figures. All 3 of those zeros are going to be significant. If we have the number 45.00, those 2 zeros are significant. Okay, they are there for a reason. Okay, they are there to make sure that because somebody measured them to be 0. If we have the number 700.0, again, we have 4 significant figures. All those zeros are significant because someone took the time to make sure that they were 0. So that is our third rule, the decimal point rule. Now, the fourth rule in this is the trailing decimal zeros, and that kind of goes along with the last one a little bit, but any zero after the last non-zero number with the decimal point is significant. What does that mean exactly? Well, if we have the number 1.000, again, that's 4 significant figures. All 3 of those zeros are significant. But also if we have the number 4.200, all of those zeros at the end are significant because somebody made sure to measure them, 4 significant figures. If we have the number 0.05000, some of you might be thinking it's 6, but this is not greater than or equal to 1. It's less than 1. We'll find out in the next video a little bit too about non-significant zeros. Those first two are not significant, so only those 3 at the end are. So again, there's 4 significant figures in that number. Okay, so those are rules for making digits significant. Now for making digits things that are non-significant zeros. First rule is any zero after a non-zero number with no decimal point. What does that mean? Well, that means the number 100, there's only one significant figure. And the number 1100, there are only 2 significant figures because these last zeros here are not significant because there's not that precision here. This first one is about 100. This is about 1100. It's not exactly 1100. Someone did not have enough precision in their measurement to say it's exactly 1100. They're saying it's about 1100. Or if we have the number 42,000, again, we have 3 zeros at the end. They are not significant. There are only 2 significant figures in this number as well. Okay. The other zeros that are insignificant are any leading zeros for a number less than 1. So what does that mean? Well, that's kind of like the last example I gave in the previous slide. 0.002 only has 1 significant figure. These first 3 zeros in front are not significant. Okay, they are just holding the place. If we have the number 0.0040, this one also has 2 significant figures. They are the 4 and the 0 at the end. The first 3 zeros are not significant. If we have 0.0001, again, this, and if we throw another 2 zeros on the end, all 3 of these at the end are significant figures. The 4 at the front are not. Okay, so they don't count towards significance. We'll get more into how this works with math with the next video.